let's get an introduction to negative exponents. And just to give you the gist of negative exponents, I think of it as moving location. That's what the negative in an exponent is telling us, is that if we're in the numerator, we need to move it to the denominator. If we're in the denominator, we need to move it to the numerator. Our goal with working with negative exponents is to turn it into a positive exponent. And to make it positive, we change location. So for example, if we have a base of x and we're raising to a negative n power, and if it helps, you could think of this as x to the negative n over a positive 1. So you can see numerator, denominator. And what I do is when I see this, that negative exponent, I'm thinking I need to move to the denominator. So that's what we're seeing in this next step here. X moves to the denominator, and now we have a positive exponent. So we flip over the division sign, and then we change positive versus negative. Similarly, if we were starting in the denominator, so we have x to the negative n in the denominator, that's telling me we need to move up to the numerator. So if it helps, you could think of this as x to the n divided by 1. So we're seeing we move up to the numerator and we get a positive exponent out of it. And we like our positive exponents because we can evaluate those mentally or with our calculator a bit more easily. So, for example, if I have x raised to the negative 4 power, seeing the negative, I'm moving to the denominator. And when I make that move, when I change location, the sign changes. So now I don't have negative 4 anymore, now I have positive 4. If I have 1 over x to the negative 5th, seeing that negative, I want to move to the numerator. So x moves up to the numerator, and that negative 5 becomes a positive 5. Let's look at some scenarios here and where common mistakes come up. I try to grab lots of scenarios here to help out with these negative exponents as well as negative values for plugging in. Okay, so 4 to the power of negative 2. So the exponent of negative 2 is affecting that 4 there. And if it helps, I could think of this as 4 to the negative 2 over 1. And what that negative 2 is telling me is I need to change location. So what I'm going to do is the 4 is going to move to the denominator. And now instead of a negative 2 exponent, because I made the move, I have a positive 2 exponent, which is 1 over 16. With this next one, we have a positive exponent, so we don't need to move anything. So I am just squaring the value of negative 4. And the negative's included, so I'm going to have a negative 4 times a negative 4, which is a positive 16. With this next one, again, that exponent's positive, so I don't need to move anything around. What's different is I don't have parentheses this time, so the only thing being squared is the 4. So this would be the same as writing like negative 1 times 4 squared. So this is negative 1 times 4 times 4, which is a negative 16. So that negative keeps hanging out front while we square that value of 4. Okay, 1 over 4 to the negative 2 power. So seeing that negative exponent, I know I'm going to be moving things. So I'm going to be moving the 4 up to the numerator. So we move up to the numerator, and that gives us a positive exponent of 2, which would be 16. Okay, what if we have so many negatives? So, and that exponent is only affecting 4. So that negative, because there's not parentheses, if it helps, you could rewrite this as negative 1 times 4 to the negative 2. And if it really helps, you could also show that you have this denominator of 1. So the only thing that's moving is the 4. The negative is staying put. Doesn't make a massive difference in this scenario, but it's good practice to have. The only thing moving is the 4. So what I'm going to have is a negative 1 in the numerator, 4 moves to the denominator, and now I have an exponent of positive 2. And with that, I can evaluate it as negative 1 over 16. Okay, those are just some scenarios where mistakes can come up. With these, just take your time, be careful. Going too fast with these, that's where mistakes sneak in. So we want to be really careful that we're following all these properties as we simplify. Okay, so 2x in parentheses raised to the negative 3 power. What that's telling me is that all of that's going to move. So if I think of that as over 1, that negative exponent tells me we're moving to the denominator. So this is equal to 1 over, in parentheses, that 2x. And now the negative 3 is a positive 3. And now I can use my other rules. So my rule said if I have values multiplying and it's raised to a power, each factor gets that power of 3. So this is going to be 1 over 8x cubed. All right, for this next scenario, this is 1 over 3 times x to the negative 4. So the thing that is being affected by the exponent is just x. So only x is going to move. 3 is going to stay put because it does not have the exponent. So 1 over, nope, we're moving x up to the numerator, so we'll have x. And then negative 4 is now a positive 4, and 3 stays put. Okay, a fun trick that I like to use when we have a fraction and a negative exponent outside is that if our negative exponent is all about move numerator to denominator, denominator to numerator, if we have a negative exponent outside of a fraction, what we could do is flip the fraction, so we can use the reciprocal. And if we flip, we now have a positive exponent. So it's just a nice little property where that negative is just telling me to move things. We can make that positive by switching our numerator and denominator. And then each value is going to get that exponent of 2. So this is going to be a 3 squared over 2 squared, which will be 9/4. Okay, with this one, we have 2 times x to the negative 7 times 5 times x to the 5th. So 2 times 5 is 10. And then we have the common base of x, so we can combine those by adding the exponents. And with these negatives, you add and subtract them just like you would any negative numbers. So this would be 10 times x to the negative 2. And to make this completely simplified, we want to go the step to make every exponent positive. So that means the x is going to move to the denominator. Again, there's multiplication there, so the 10 is not going to move because only x has that exponent of negative 2. So we're going to have 10 divided by, and then x in the denominator, now with a positive 2 exponent. Okay, let's go through some examples here where we're mixing these rules together. And if you can, go ahead and pause the video, try to simplify these as far as you can, and then you could check your answers along with this video here. Okay, with this first one, what I want to do is first simplify inside the parentheses. So what I'm seeing is I have 2 values that are multiplying with a shared base. So what I can do is combine those, n to the negative 1 plus 3. Let's go ahead and write these out. As you get used to these rules, you don't have to show all of these steps, but I'm going to go ahead and show them just for the sake of clarity. So this will be n squared times m raised to the power of 4. And that exponent is going to go on n squared and m. So we're going to have n squared to the 4th power times m to the 4th power. N squared to the 4th power is the power to the power rule. So with that, we're going to multiply. So that'll be 2 times 4. And then we have m to the 4th So this will be n to the 8th power times m to the 4th power. And I'm showing lots of steps there. You'll get comfortable with these and move a little more quickly. But with that, show what work you need so that you're kind of checking your steps as you go. Okay, with this one, let's go ahead and take care of that exponent of 2 and having it go to each piece inside of the parentheses. So the first thing I kind of thought about was if there was anything in the parentheses that needed to be simplified, but there wasn't. So I have this a cubed b squared outside, and then we're going to have this a squared raised to a power of 2 times b to the negative 1 to the power of 2. So here's my power to a power rule. So I still have this a cubed b squared times a to the 2 times 2. So we're multiplying our powers together. So that'll be a to the 4th times b to the negative 2. Okay, I'm looking for my common bases. So I have a cubed and a to the 4th. So I can combine those by adding the exponents. So 3 plus 4 times, and then with b we have 2 plus a negative 2. Just be careful with those negatives that you use parentheses. So this will be a to the 7th times b to the 0 power. And whenever we're raising something to a power of 0, it turns into a 1. So that is really a to the 7th times 1, which is just a to the 7th. All right. They're getting messier, but it's good to go through these examples together. Okay. Let's go ahead and bring through this exponent of 2 into those parentheses. So we still have these big parentheses. We're going to have x to the negative 2 to the power of 2. So we're going to multiply. Negative 2 times 2 is a negative 4. And we have y squared. So we have 2 to the power of 2. So we multiply 2 times 2 with a positive 4. And then we still have this y to the 4th hanging out outside. All right, and then xy to the 4th, and then this big exponent of 4 outside. Okay, let's go ahead and in the numerator, combine y to the 4th. So we would add them together to make y to the 8th over xy to the 4th, all raised to a power of 4. Now I'm going to go ahead and use my subtraction rule. So I'd have x to the negative 4 and then minus 1 from the denominator, and then times y to the 8th minus 4 from the denominator. Oh, and let's see where I'm going to put all this work. I'm writing quite big today. All right. So this will be x, negative 4 minus 1 is a negative 5. Y, 8 minus 4, which would be 4. Okay. We're going to bring that exponent of 4 on the outside to each of these pieces. So, x raised to a power of negative 5 raised to a power of 4. We multiply those together for a negative 20. Times y, 4 times 4 is 16. And it looks like we're done, but we have one more step, and that's because we have a negative exponent. So x has a negative exponent of 20, so x is going to need to move location, in this case to the denominator. So y to the 16th is going to stay put, but x is moving to the denominator, and now we have an exponent of positive 20. And that'll do it. Okay, let's see what's going on in those parentheses in the denominator. So I'm going to have b to the negative 2 in the numerator over, and then in these parentheses I have a to the 4th times a to the 5th. So I could add those exponents for a to the 9th from that 4 plus 5 times b to the 3 plus 0, which is just going to be b cubed, raised to a power of 4. And that exponent of 4 is going to go to each of those pieces in the parentheses there. So we have b to the negative 2 over a to the 9th raised to the power of 4. So 9 times 4 is 36. B to the power of 3 raised to a power of 4. Multiplying those, we'll have 3 times 4, which is 12. Okay. With these, there's a few different ways to go about this. My way is not the one and only way. So as I'm doing this, I'm thinking of all the different ways we could do this. I am going to, and it's going to get us to the same spot, so it doesn't quite matter, but I'm going to go ahead and move this b to the negative 2 down to the denominator. So what that's going to do is leave me with a 1 up there. I'm going to have a to the 36, b to the 12, and then this new b squared in the denominator. So I get that positive exponent of 2 because I moved down there. And then what I could see is I have these expressions with base b that I could combine together. So what we'll have is 1 over a to the 36th power, and then times b, and then 12 plus 2 is 14. And that will have us done right there. Okay, 2 more examples here. I know this is kind of a long video, but I want to get you lots of examples with these. Okay, let's start with that exponent of negative 4. Yeah. One thing that's a little tricky here, I'm actually going to draw a third arrow to show this negative 1 that's out front here multiplying. Because we really have this negative 1 times x squared times y squared. Okay, so let's keep this negative xy to the negative 4, and then we're multiplying with negative 1 to the negative 4 power times x squared to the negative 4 power times y squared to the negative 4 power. And let's go ahead and move things. Anything that's negative, let's move it to the denominator. And I just want to see positive exponents here so I can start evaluating things a little more easily. So something to notice is this negative x is staying put. That is the only thing that does not have a negative exponent. So we're going to have negative x up in the numerator. In the denominator, we're going to have y and then to the positive 4 times negative 1 to the positive 4 times x squared to the positive 4 times y squared to the positive 4. So we'll have negative x, y to the 4th. Negative 1 raised to a power of 4 is just going to be positive 1. So again, it's important to notice that the negative is in the parentheses. So it's going to be negative 1 times negative 1 times negative 1 times negative 1, which all just goes to positive 1. And then we'll have x to the 8th by multiplying the 2 times 4 times y to the 8th from the 2 times 4. And then our last step could be go ahead and combine those y values in the denominator. Ooh, sorry, not last step, almost last step. Y to the 4 plus 8, which is 12. And then we have an x that can cancel out across the numerator and denominator. So with that, there's going to be none left in the numerator and only 7 left in the denominator. And there's a few ways to think about that. You could think of it in terms of cancellation. You could also think of that as x to the positive 1 minus positive 8, which would leave us with the x to the negative 7, which would give us that x to the 7 in the denominator. Okay, last example here. Okay, exponent of 2 going in here. Again, I see that negative symbol, so I'm going to think of it going to the negative 1. Same thing with that exponent of 3. So I'm going to have a negative 1 squared times x to the 4th squared times y cubed squared times a negative 1 cubed times y cubed times x to the 5th cubed. Okay, negative 1 squared is just positive 1. X to the 4th squared, 4 times 2 is 8. Y cubed squared, 3 times 2 is 6. Negative 1 cubed is a negative 1, so I'm going to go ahead and put a negative symbol out front from that negative 1 cubed. Then we have a y cubed, and we have x raised to the 5th power raised to the 3rd power, and multiplying would give us 15. So we'll have a negative x. 8 plus 15 is 23. And then y to the 6 plus 3 is 9. Okay, big video there with lots of examples, just finding the method you kind of prefer and simplifying down following all of those exponent properties.